Okay, so hello YouTube, day 15, let's get started. Keton. What? You've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit though. The main problem is that the walls of the cave are covered in ketones, and it would be best not to bump into any of them. Oh. I see, there's like ancient Pokemons on the sides of the cave. Dandruff, thank you for the follow. Welcome to the stream. So, the cavern is large, but it has a very low ceiling, restricting your motion to 2 dimensions. Convenient, very convenient. The shape of the cavern resembles a square, and a quick scan of keton density produces a map of risk level throughout the cave, your puzzle input. For example, okay, you start in the top left position. Your destination is the bottom right position. Okay, so this is the entrance, this is the exit. And you cannot move diagonally. The number of each position at each position is its risk level to determine the total risk of an entire path. And up the risk levels of each position you enter, that is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Okay. Also, tomato pasta, thank you for the follow. Big fan. Okay, so your goal is to find a path with the lowest total risk. In this example, a path with the lowest total risk is highlighted here. Okay. The total risk of this path is 40. The starting position is never entered, so its risk is not counted. What is the lowest total risk of... What is the lowest total risk of any path from the top left to the bottom right? Okay, so it's basically the same thing except on our own input. So... is this just the extra? I haven't implemented this extra in ages. Like, you just want to find the lowest path? That's it. Like, I think there's nothing much more to it. Except actually implementing the extra. So, this is funny. A-star maybe... Well, okay, oh man, I don't remember this stuff. But isn't A-star and the extra the same thing? Like, I think that the only difference, if I don't misremember, I think the only difference between A-star and Dijkstra is that in A-star you have a way of, you have like something that tells you an approximation of what's to come, like of the rest of the path, and that's something that you add into the mix. But like, unless you have a good heuristic, you basically have the extra. I also don't remember, I think the heuristic also needed to have another characteristic, like it needed to never underestimate, I think. Like, it could overestimate as much as it wanted, but it should never underestimate. I'm actually not sure. So without that, I don't know, maybe somebody who knows this can answer the question better, like, I don't know, like specs. But yeah, I think that Dijkstra and A-star are pretty much related. And I don't see a good heuristic here, because normally what you could do is like use something like what's it called? Oh my god, the distance on a grid. Manhattan distance. Oh, thank you. Yeah, Manhattan. So you can use that, but I mean, in this case, it's not great. And it's gonna be... Oh, but you know what? Instead of doing Manhattan distance, I could do basically the weights on the Manhattan distance, and that's gonna be surely an overestimation. Like, it's not going to be an underestimation. I think it's fine. I don't remember though. Is the heuristic is allowed to overestimate, right? And not underestimate. I don't remember, but I think that Dijkstra, it's easy. Looked it up. Dijkstra is A-star without the heuristic. Yep. Yeah. Also, Dijkstra or... And so it's up to you if you want to say, no, Dijkstra, yeah, so heuristic can never overestimate. Fuck. So it can under but not over. So it means that we cannot do this thing. There are no zeros, so it would work, but you don't need it. This is fast enough. Yeah, I would assume so. I mean, let me look at my input. Let's see how big it is. Okay, that's something. We definitely need the extra here. Okay, let's do it. Oh, IT equals Manhattan distance. Right. So Manhattan distance will not overestimate because there are no zeros. Yeah, thank you, Martin. That now makes perfect sense. Yeah, but I don't know. I mean, whatever. You know what? It's easy to add it, right? You can add it in case things go wrong. But even then, I don't think, like, how much of an improvement is A-star over Dijkstra, like having the heuristic? I think it might be a great improvement if, like, your space is weirdly shaped, and in the heuristic you can add, like, you can bake in weird knowledge about the space. But if you don't have that, I don't think you even get much out of A-star compared to Dijkstra. I have no idea, to be honest. This is just like a hunch. So out of curiosity, has anybody here ever had to use Dijkstra professionally? I'm guessing maybe Martin will say yes, but seriously, I have never, and I'm not saying this in the sense of, oh no, they teach us useless stuff. Maybe the opposite. It's it would be nice if we had interesting jobs that required us to do this stuff, but I have never done this. I use some computer science concepts occasionally. Yeah, okay, so Martin, yeah, but you make games, so you don't count. No, I never had to find the exit from a dungeon, okay. So here's the problem number 2. How do we implement Dijkstra? Actually, problem even before that, how do you type Dijkstra? Is this it? Okay, that's how you type Dijkstra. Man, so I haven't implemented this in ages. Also, in my university, we had this entire dynamic programming section where they wanted to present every freaking algorithm from the perspective of dynamic programming, which in my opinion, I don't know, I guess it's not completely useless, but I don't know, I don't like it. And I think that like there are a bunch of ways of implementing it, some are better than others. So yeah. Oh yeah. I think this is the best way, right? Okay, I don't know if it's the best way from the perspective of performance, but like you basically have the priority queue do all the work. I think we have one indices on the library. I'm not sure. I think I saw it though. Oh. I think today might be... I think A-star will benefit heavily here. You basically explore only the diagonal instead of radially out from the start. I mean, you will prioritize that. So you will prioritize, I guess, yes, you add the knowledge to... So basically, you could say that the knowledge that you bake into the search is the knowledge that the bottom right corner is where the exit is. I'm not sure how much of an improvement there will be though. So that's a fair point. The extra knowledge that you can bake into the algorithm is knowledge that the x is on the bottom right corner. Otherwise, the algorithm just doesn't know and starts searching everywhere. But how much? I mean, we could actually. Okay, let me actually solve this, because we might spend 4 hours just trying to solve the basic problem and not have the luxury of doing anything. But if I don't spend an insane amount of time trying to solve the thing normally, we could try to pit Dijkstra versus A star in this case and see how much of an improvement it is. Although you can see how maybe an evil input could require to do like an S. And I think that if we have to do like an S, like imagine that there are like 2 mountains in air quotes, and you have to like cross one, then go up, cross the other, and then go down. I think at that point, like that would be a type of input that would, where the heuristic would not help much because of that. But we'll see. Why would you say close the diagonal? Manhattan distance doesn't give any bonus to that. I think the Manhattan distance is worse for points far away from the diagonal. I'm not sure. I can do tests with Dijkstra versus A star, but the Manhattan distance is not so good at keeping you on the diagonal. Okay, so you... Yeah. Well, I mean... You can cheat a bit, right? You can, like, you don't have to be... Wait, let me double check what exactly is the Manhattan distance, how it's calculated. Is this really the sum of the 2 sides of the triangle? Taxi cab geometry. It's calculated as the sum of the absolute differences between the 2 vectors. Can I have like a better explanation that actually helps me understand? Measure along axis and right angles. Okay. So, you know what? Let's get to the problem at hand. Oh, no, I didn't want to do this. Good thing the board didn't crash. Oh, no good either. Excuse me? Oh no, I think I did something bad. Okay. Oh no, is this the old bug? This is the old bug. Oh my god, I haven't seen it in ages, and now it's back. No! Please. Please, Apple, do something. Oh, man. I think I need to restart the Mac. Or rather, I need to log out. So this can be paused. Somehow. Maybe. Right, I don't even get access to the side menu at that point. I think I can do quit, and that should automatically suspend this. Yes. Oop. Okay, let me... Ooh. Let me go full screen camera. was annoying. I didn't have this problem for like ages, to the point that I thought it was somehow fixed. But I guess rebooting somehow broke the beautiful equilibrium I was in. Kind of disappointing. So I think I'm almost done. Okay, so we need to test Borg. Can somebody send a message to see? Okay, I think this Borg should not be connected anymore. I think it should be dead. It just doesn't know it. Yeah, so this Borg is dead. So we need to do Borg start. This actually gave me an idea, which is in hindsight so obvious, and I don't know why I haven't done it yet. But I want Borg reconnect. I want the Borg reconnect command so that from the outside you can trigger a reconnection. It's so obvious. I don't know why I don't have it. In any case, let's go do what we need to do. So cd AUC 21 Nick shell day 15. Is that a Linux VM or what is happening? Yes, that's a Linux VM inside a macOS host. Maybe try Chatterino. Aukras, I'm so tempted to time you out from chat. I'm the proud creator of this chat application, and I don't want to use anybody else's chat. I mean, Chatterino is fine, but Chatterino doesn't seem to me to be really designed to be a streamer's chat. I think it's, I don't know, you can use it, I guess, if you want, if you're a streamer. But I want to make a chat application designed for streamers. As for the history of chat, maybe I'll implement something like that, but for now I'm not entirely sure I want to. I need to add like a bonk command, like to ban somebody for 10 seconds or something like this. It's just like dunk. Okay, so touch, input, touch, in the zig. Then Sublime. Day 15. So let's use the simple input, I guess, as a starting point. Although it shouldn't be this bad. I think I remember this was super easy, but I know I can't get too confident because I'm gonna mess it up. So let's see. Bonk command should be hitting applications with a big wooden hammer so they get it together. Yeah. Okay, so let's see. I think we can do this as a starting point. Close without saving. That's our input. That's our main. Okay. So I was looking at my priority queue. So we do have a priority queue, so I think we should try to use it. Priority queue for storing generic data, initialized with init, provide compare function that returns order.lt when the first argument should be popped before its second argument. So this is a min queue. So like min first. Cool. That's actually, I think, also what we want. Order queue, if the arguments are equal, order GT in the other case. Also, is this order something defined in here, or is this something shared with math? Oh, it's shared with math. So can I make like no, I can't make anything, never mind. I was thinking maybe I can use math dot something, but no, I can't, because I need to pass in like I need to make a type with the score and the freaking coordinates. Good for you, ended up copy pasting a priority queue implemented earlier. Ooh, Yeah, I'm lucky in this case. So let's do it. Then, okay, let's start by parsing though. So we need to parse. Where do we put this stuff? A matrix? So this is gonna be 10 by 10. Oops, no. So let's do a matrix 10 by 10. So there's no rules. But there is a, I don't know, caverns. Of type 10 by 10. What do we put in each place? Just a number. We don't initialize it. We don't initialize it. Oh, now we have again the question: do we stay in character space or do we not stay in character space? I think we copy the initialization line by line, but also moving away from character space code. I think I had it one of the previous days. There we go. I like this. So let's copy this. I also like space. Okay, so that's our space. For each row in the space, we let's not hard code 10. I saw that my input is bigger, so let's use the dimensions of space in this case. So we copy everything over, and then for each thing we remove the 0. Okay. Oh, sorry. Yeah, that was notification noise was from me. Windows doesn't have a good way of saying like stop notifications from stuff. I always have to close the chat application, which is super annoying because actually the Mac gets that right so much more easy. Like on the Mac, I'm constantly in do not disturb mode. Oh, so let's enable never sleep mode, and I'm good. Okay, can I fix this now? Okay. Wait, there is a Windows machine too. Yes, of course. I'm streaming from another machine. So this is a Mac laptop. Mac M1 Mini, a Mac Mini, not a laptop. But for streaming, you don't want to stream from Mac nor Linux if you can avoid it. OBS is much more better on Windows, more featureful. So my main computer is Windows, basically for OBS, maybe a couple of games, DaVinci Resolve. That's it. I guess I could add Office to the list, although Office on Mac is mostly good enough. I didn't expect the 3 OSs involved in the stream. Yeah, that's such is life, right? So you want OBS working well, you need Windows. You want fancy apps that look nice and cute, like graphical apps that look fancy and cute, you need Mac. And I actually would say also for the hardware, for the M1 is cool. But then you want to be able to debug applications and have a nice tiling, Windows Manager, etc. Then you need Linux. Okay, so I think we're parsing correctly now. Are we tokenizing correctly? Well, we can tokenize on the new line. So this parses our space. Now, priority queue, right? What was that about Linux? Well, you need Linux if you want to debug easily native applications, like native programs that don't run inside a virtual machine. And also if you want to have certain types of fancy graphical stuff like a tiling window manager. Like you can try to emulate tiling on Mac, but it's not gonna look as good as this looks. So priority queue, const. We need to specify our types for our nodes, right? What should I call it? Chord? Pause? I like pause for position. So each position has a x coordinate, Should I just do usize? I think I'll do just usize. Coordinate x, coordinate y, and a score. I'm also tempted to cast this to usize, although I won't be able to copy everything over like as nice as this though. I could do a for loop though. Okay, we'll see. Not a fan of Visual Studio for debugging. I don't want to program on Windows at all. So I'm not a fan of Visual Studio, period. I know that the debugging experience is better. Like, it's not bad, it has a bunch of features. The problem for me is everything else related to Visual Studio. 45 minutes to install it, keeps shitting itself for no reason. I used to work at a company where we were doing like C#, and we had this solution with, I don't know, 15, 20 projects in it, and like it was a complete shit show. XML everywhere, not understanding why the thing doesn't work. Like, the thing that I hate the most is when the thing breaks and you have no way of knowing what the heck is going wrong because it's a giant pile of garbage. So I really, really hate that experience. I'll take the command line experience of GDB for debugging, minus the jank, over the yeah, honestly better debugging experience of Visual Studio, but with all the jank. Plus Windows, I don't know, I hate Windows for programming. Like, the terminal is so bad. 120 projects in a solution, oh god. Yeah, it's a disaster. It's I don't know. I don't want to touch that stuff anymore, ever again. Okay, so we need to make our priority queue. So const pq is gonna be std dot priority queue. Okay, what do we need to pass to it? A type and a compare function. So the type is POS. The compare function is going to be POS.cmp, I guess. So pub function cmp. It's going to be like p1, p2. And returns std.math.order, I think lowercase m. And the question is whether the first one is lower, right? That returns order.lt when its first argument should be popped before its second argument. Oh, so like you can actually, so that's not even really a mean queue. Like, you can cheat in the compare function. Obviously, you can cheat in the compare function and do whatever you want with it. Okay, so I guess we want to say if p1 dot score lower than p2 dot score, we return lt. If p1.score is equals to p2.score, we return pq. Oops. Otherwise, we return gt. I think that's it. So let's see what people are saying. Are you also using Visual Source Safe? No, we use SVN. Oh no. Return on the same line as the if. Finally, a bug shed we can argue about. Should it or should it not be there? I don't know. So I can tell you the answer. The answer is whatever Zig format allows, we should be fine with. Also, what am I missing? Error expected semicolon found pub. Oh, here. So format allows it, so this is good. Format also allows this, so this is also good. This is the answer. Both are fine. Whatever Zig format allows, that's the truth, the ultimate truth. Okay, to have a compare function, are we good? So this gives us the PQ type, yes. I'm not used to seeing compile times game milliseconds, man. I got like compile times at my company got so bad that at one point I was so annoyed by that. Like they probably were far from the worst possible, but I was really annoyed at the situation, and I got to the point where I started pushing so that the CI would run the compile instead of compiling locally. And I don't know, I was doing this as a form of like silent protest. So could you return math order p1.score, p2.score? No, because... Oh wait, you mean in here? Yes, I think I could. Holy shit, thank you. No, wait, I'm not sure. Is math.order... I need to make math.order... I think math.order is generic, isn't it? We saw this stuff when sorting already. Or actually, I don't know if math.order... Maybe you're referring to another function. I was thinking of the sorting stuff that we were doing. I was sorting even yesterday, right? So we can find sorting... So, okay, oh, this is sort.ask. So math has order. That's awesome. Like, if this is a thing, holy shit, let's do it. Even better. Okay. Then what else do we need? So we have our space. We filled our space. Then we have our PQ. Dot init, I guess. Okay, now here's the hard part. Now we actually have to do it. So I think you keep, the way it works is like you start from the first node, like you push in the first node. Then you have this while loop that pops it out. If it's the end, we're good. If it's not the end, we need to expand it. So we look at all the places that we can go from that spot, put them in the queue, and then continue popping. The queue will start popping the most promising one, which then we will expand, which will put more nodes in, and it will always keep expanding the most promising one. And that's, I think, all our algorithm. Is the extra more complicated than this? I think the fucking dynamic programming explanation was way more complicated than this. I think that this is it. So q dot, I don't even know the methods. Push, add, insert a new element, maintaining priority. Oh wait, also I think no, never mind. Add unchecked. Sift up. What's sift up? Oh, it's. Oh wait. These aren't even public, so we don't know. Add slice. Nice. Peek. So nice. Remove or null. That's what we want. So this is pop. Nice. What does the exclamation mark before the return type mean? The exclamation mark means that it's an error union. So if you're familiar with, I don't know, Rust, for example, in Rust they have this generic type where you have the error case and you have the success case. And the success case is what contains the normal result value. That's somewhat the same in Zig, but we have special syntax. Like in theory, you could have like a normal generic type that you make yourself. Like nothing stops me from doing this. Do you put dots in here? I don't remember. Do you do dot okay? No, I think you don't. Or in our case, errors are basically numbers. I think it's a U16. So you could make this yourself. So our errors don't have a payload. That's what I'm trying to say. So you could write this yourself. Okay, apparently there's some missing semicolons. Line 5. Yes, that's a function instead of a const. There we go. So you can make this generic type, and basically you could have then function foo that returns result of, I don't know, a position. And so in there you could return a position, or you could error out and you will return an error. And that's exactly what the exclamation point does. But error unions in Zig are special case in the language, because Zig gives you a few utilities around that. It gives you, for example, it's able to know what the possible error values from a function are, and it allows you to enumerate all of them when you need them. And also produces error traces automatically. Our errors are just numbers, but if this were, I don't know, Go, programmer, thank you for the follow. So if this were Go, in Go, every time you pass an error around, you kind of need to add context to it, because otherwise you don't know exactly that error, which path it took, until you panicked from it. And I'll answer that in a second. So you basically, what ends up happening is that if you look at the stack trace only shows you the stack state, the state of the stack. So it shows you where you were when you panicked with an error. But before then, when you pass that error around, you don't know anything about it, because these functions are not in the stack anymore. So Zig automatically produces an error trace for that, because errors are a special type. And I can show these here. Error traces. Errors. So errors basically are enums. So you can give them a name. You can create them on the fly. In the case of Advent of Code, you don't really see them much, because I'm not doing proper software engineering. I'm just running towards a solution, towards an answer. But so for example, you have a bunch of functions that so this function bar, I think, is the deepest one, or maybe not. So main calls into foo calls bar, and bang2. Okay, so these freaking functions all call each other, and I think bang1 and bang2 are the ones that are probably the deepest. So they can return these errors, and you see they have the exclamation marks. Another, the keyboard try, is basically a shortcut of saying, if this function returns an error, then return it immediately. So they also return errors, because they basically forward up errors that they get. And here, for example, you even have this case where if the error is file not found, then another function is tried. And when you then get an error that bubbles up until the end, you also get this, which is the path that the error took, even to the point where it got remapped to another error through the to the switch case, up until here. And this is where the actual stack trace starts. So it's a built-in way of having providing context to errors, and it's pretty cool. So that's why there's this special syntax with an exclamation mark. So what keyboard are you using? I'm using, well, this is half of it. It's a Korn. If you search for, I think QMK Korn is the full name, CORNE. Okay, this is a website that sells it. It got auto-completed, sorry. Yeah, Matt, I think it might very well be my final destination in terms of keyboards. Do you use it for gaming? Not much yet. I used it a little bit. It's fine. Like if you're using, I don't know, if you're playing a game where you need a ton of buttons, maybe not. But like for a first-person shooter, is good enough. And it's also nice that you can like move away, like the right half, so that you give yourself more space for your mouse. I think I saw multiple enums that function as error types. How do you know which one you are getting? How are they namespaced? You should read the documentation for a full explanation of this, but long story short, you can define these errors. You can define them on the fly when you don't want to be too precise with them. But if you need to have like complex error handling and you want to be precise with it, and so for example, this is usually the case with libraries, you basically create them as sets, and then you use a more explicit syntax where you don't just put an exclamation point, but you put also the error set name. So I don't know, pause error, and you say that const pause error can be one of I don't know, bad Pokemon. Error, whatever. So at that point, you're stating more clearly that these are the possible errors, and it's nice because if you at this point, if you try to return an error, like if you try as in the keyword try to do something that is not in this error set, Zig will complain. So I think I can actually show it. Because I think that adding stuff to the queue is a try. So you need to do try queue dot add position. What is it? 0 0 score equals 0 also, because I think we didn't have to pay for the score from the original thing. I think the exercise said that a couple of times. So if I do this, queue.add will return an error that it's not in my advertised error set, and I think this thing will complain. So let me fix the compile errors first. Then let's see what happens. Pause error. Okay, what are the errors? Express identified found error. Oh, do you not put error dot in here? Oh, you don't put error dot in here. So I keep forgetting how to declare stuff. Okay. Then? Okay, that was it. So let's try to run it. Missing parameter name. Oh, that's actually fair. Okay, expected type POS error found something different when doing try. Okay, this error message is not the best. This error message can be improved. But you see that this error, basically, it's not in our pause error set that we were advertising. So here's what we can do. I would expect it to tell me what error this is. I think it's unfortunate it doesn't tell us. Oh no, it does. It's underneath here. Note. Error.outofmemory is not a member of the destination error set. It tells us. Nice. So after this error, you can say, okay, so it turns out that actually out of memory then is something that I need to think about, and now it works. Yay. But normally you don't want to do this bookkeeping explicitly. Again, if you're not if you're doing proper software engineering, like a library especially, you do want to be precise with this stuff. But not always. So like in the standard library, I think it's a good example of people being more clean with error bookkeeping. Let's see. I can't wait to show up at some for you to show up at some conference with my corner parts. Wait, your corn pants? What are you talking about? You have corn pants? The tricorn toque? What? Okay, So priority queue, we add the initial position, then while queue dot remove or null, I think we get a position, and what do we do in there? So if it's the end, we leave. So what is the end? The end is in the case that it's x, p dot x equals is my input going to be a square? I think the exercise said that these are going to be squares. Okay, so let's assume that those are always going to be squares. So let's cheat and just say space dot len minus 1 and p dot y equals space dot len minus 1. Then the score that we computed there in P is the end, I think, because we expanded it in the frontier, and we should have set its score to the cumulative score of the actual path that we took to get there. Hopefully. So std.debug print and so we print the score and we are good. We return. Okay, otherwise it's not the end. If it's not the end, then we need to expand it. So, oh my god, we are again in the situation where we need to come up with new coordinates and we have borders of this thing. But I learned my lesson. I won't do a mess this time, and I think I know what to do. Const. I don't know. Expansions. Expansions is going to be oh man. So let me look at the input. So we are here. In our case, it's gonna be these three. But let's say that it's here. What do we put back in? I guess we should avoid putting in the point that we just added. Ooh, so what happens if I like went to 3, then to 5, then to 1? I should... What do I do at this point? Oh wait, I cannot go on diagonals, so that's true. So okay, no diagonals, that's nice. So if I avoid where I came from, I add the others, but what if somewhere where I went to already? Then it's fine because we just toss it in there and we're never going to expand it because that point has already a better way of doing that, so that one will get expanded first and our weird loop is always going to be ignored, I guess. There's no really another way of doing this, I think. So I think it's fine. Okay, so my expansion is basically going to be it's an array of 4 positions. early numbers are showing that for my solution I start with Manhattan distance is slightly slower than the extra, even that. I guess the extra word of preparing the heuristic is more than the savings. So x equals dot y equals, and then dot score equals, and actually this is what I should be copying. So okay, here's what I learned. I'm gonna do position. So up above is same x, lower y, right? So I'm gonna do y minus modulo 1, and score is going to be my score plus the score at that cell. So my score is gonna be p.score plus, or you know what, oh yeah, let's do it now. So p.score plus space, oh my god, I need to copy these, I guess. Oh no, wait, I wanted to, oh my god, I wanted to do this later. So, okay, so here's what I'm gonna do. I'm gonna leave the score to 0, because I'm going to change it later. Here's my cheat. So let me do the order. So this one is up. Then let's do left. Left is going to be x minus percentage 1. Y is going to be the same y. Then down is going to be y plus 1, and x is going to be same x. And is this soothing background music finding its way into your headset? Is so even more impressive problem solving skills. Yes, I'm listening to it. How's the part 2 for today? I have no idea. Hopefully I'll get there soon. So this is right. So right is going to be same y, but x plus 1. Why is there a percentage before 1? Is this for unchecked arithmetic? So here's my trick. Or rather, here's the problem statement. The problem statement is that if you're using unsigned numbers and you are at coordinate 0 and you try to do -1, you overflow or you underflow, right? So you wrap around to a huge unsigned number. And the problem is that it's annoying because then you have to check first, and it adds a bunch of it's annoying in the code, like the typing experience. My problem is not what the machine is doing. I don't care in this case about what the machine is doing. My problem is I don't want to go through the pain. Like, look at me not knowing how to solve this stupid problem a few days ago. I ended up with with this. It's like a bunch of checks maybe get just because, and even then I was using the percentage trick already. So just because I didn't know how to produce these stupid positions. So the percentage, actually, is it clamping to 0? No, clamping, I'm not sure exactly what clamping should be doing, but we also have saturating arithmetics. So we could do this if we wanted. So like if x is 0, and you try to subtract 1, it stays at 0, but that's not what I want to do because it's gonna give me the wrong value. What I want to do is explicitly ask the wraparound, have the value become giant, and now I can do this. For expansions, p, oh no, I already have p, new point, and p. So for expansions, if np.x is lower than space.len and np.y is lower then space.len, then I process it. So the idea is that I'm basically making the going negative case collapse into the too big case. And so I'm saving myself some typing. The entirety of this thing is just to save myself some typing. I don't know. So I swear to God, this stupid problem of producing nearby positions on a matrix, it's like it's the hardest thing that I've encountered so far in the advent of code. So the problem though is that I can't compute the score yet because I don't know if these indices are valid. So I'm leaving them basically unset. Actually, to be precise, that's what I want. I want to leave them undefined. I don't want to set them to anything. And then in here, once I've confirmed that they actually are valid coordinates, then I set that. So I set np.score equals p.score, the original point .score, plus space np.x np.y. There we go. I like std bounded array as a temporary buffer for building a neighbor list. Also, there's another thing. I'm adding the point itself, so I should also avoid the point itself. So I think I'll do this. If np.x equals p.x and np.y equals p.y. I don't think it makes much of a difference, but so also nice how this is a continuum, like this is a guard style thing, this is a nested style thing. I don't care, it's fine. It will never be equal. I think it could. I'm dumb. I think I'm dumb. Why am I dumb? Oh, right, because I was thinking of the point where I was coming from, but I completely, so it's not P. I was thinking the path that I took to get there, but I've already lost it. So I will every time necessarily try to also consider going back because I don't know where I came from. Right. Thank you. That's a good point. That's a good point. Maybe for an optimization, I don't know if it's worth it, but like you could also remember for each position where you came from so that you avoid redoing it again. Maybe. In any case, so now we set the score and now we add it back to the queue, right? Q.add np. Also, wait, I'm modifying np, so I need it as a pointer. So that and this needs to be var. So this needs to be a modifiable array. I need to loop over them as a pointers because I need to modify to be able to modify them. This syntax doesn't need to change because we can do dot on pointers too. But I think that this needs to be like this. So let's see, no memory allocation and lets you build a quick list and then process neighbors in a loop. But what's the... so what you're saying, you're talking about a more generalized case, right, than these ones, I'm guessing. Because in this one, like, it's fixed, right? It's 4 possibilities. So, like, you don't gain anything by using something more complex. Oh, no, I think I see your point. It's like, it's because then you don't have to do the, like, you do the filtering as you build it. Is that it? Like, you avoid putting bad stuff in it in the first place. And then you don't have any filtering in the loop. So I think this is fine. Do we need to do anything else? I don't think we do. So 0 main. Well, we need to make it compile. That's fair. So this is all p.x, 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 p.y, 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 p.y. Then error is ignored, consider using try. That is absolutely fair. This is not good. Also, this is taking a lot of time. This should definitely not be taking this much time. If it takes this much time on such a tiny input, I'm doomed with a big input. Okay, what am I doing wrong? So this is not it. We clearly never got inside here. I think that's the problem. Is this condition wrong? I think that condition is wrong, isn't it? So the first coordinate is, sorry, this is 0, 0. Zero, 0, 1, 0. Am I mixing around x and y everywhere? I don't think I am. Don't always add all neighbors. Otherwise you'll search forever. Oh, you need to keep track of which points you have visited, otherwise you will never finish searching. Oh, right. Oh, that's a good point. Right, I need to keep track of that too. So, right. That's what I was talking about. It was actually important. Not to forget about that. So what's a good way of doing it? I can make another matrix, I guess. So visited, something is visited once we put it inside or once we pop it. I think it's once we pop it, right? I'm actually not sure when it is that you should consider it visited. Once you pop it, okay. Okay, let's do it. So known space. Wow, I'm such an artist. Bool, and we can make it like this. std.mem.zeros. Equals true, and here we add stuff is if it's in a reasonable range, and well, we can add another thing here, and if it's a known space. Except that I have found bool. Oh, what am I doing? Oh, this is known space. Result 40. Result 40. Okay. So puzzle input. That's 100 by 100. I think we can do space.len. Okay. 717. Nice. Part 2. Now that you know how to find low risk paths in the cave, you can try to find your way out. The entire cave is actually 5 times larger in both dimensions. Okay. The area you originally scanned is just one tile in a 5x5 area, tile area that forms the full map. Your original map tile repeats to the right and downward. Thank God. It doesn't also repeat on the opposite directions. Each time the tile repeats to the right or downward, all of its risk levels are 1 higher than the tile immediately up or left to it, or left of it. However, risk levels above 9 ramp back around to 1. So if your original map had some position with a risk of level of 8, then the same position on each of the 25 total tiles would be as follows. Okay, so 8, so this is like the zoomed out version of the map, where this is what the tile that we had. This is like a 1 position 8 on the original tile, then to the right it goes to 9, and it wraps around to 1, 2, 3. Okay, so it's very symmetric in that sense. Wow, look at those diagonals. Okay, each single digit above corresponds to the full example, to the example position with a value of 8 on the top left tile. Okay, because that's 5 times larger. Here's a full 5 times as larger version. Okay, so this is actually not just like one example, but like the full version of it. So this was the original tile. Oh my god, why did you do this, Mac? Okay. Equipped with a full map, you can now find a path from the top left corner to the bottom right corner. Holy shit. Wait, this is much bigger. I guess we could build the full map and just iterate over the full map. But maybe we can like somewhat produce the full map programmatically from while doing the extra, hopefully. So let me copy this, please. Oh, so I don't know why mouse selection is so janky in this setup. So I want to call the one below main one. Okay, so let's say that our space is still this big and we still copy everything over. Although I think known space needs to be bigger at this point. But this is the moment where I actually realize that known space really shouldn't be a matrix. Well, it's not like unknown space is exactly sparse. But I think in this case, I don't know, we can make it 5 times bigger and just... I think we can afford this being 5 bigger. I was about to say maybe we should make this a hash map, but you know what? I paid for the 16 GB version of this machine for a reason. Right? Like, I paid for the RAM, I want to use it. You could use a bit set, true. Only 16, well, that's the max that you could get with the M1. Like, the new one can go up to 64 gigs, but this one just has to up to 16. You probably can build Solana. Well, such is life, I guess. So we have our tiny space. We keep pulling out of it. But now, holy shit, now this has changed its semantics. Ooh, and would you look at that? So there's this funny thing where I delayed setting the score to here, and now this quirk that I put in because of stupid negative numbers, I now can abuse of this even more and use this to basically compute the score as I add it. Nice. So we're getting these coordinates. Now it's not just that the x and y needs to be lower than space.len, but they need to be lower than space.len times 5 and lower than y times 5. They must not be known space. And now what is the score? The score is the score for P. Yes, but now it's more complicated, right? So I need to know how many tiles I am to the side and how many tiles I am, well, to the right, and how many tiles I am going down. And I need to use that information to manipulate the value inside of space, the score inside of space. Oh my god, my brain is melting. So let's do this. Const base score is space this, oops, is space this modulo 9 wait, what am I doing modulo 9? Okay, wait a second. Why did my brain go to modulo 9 when... No, modulo 9 is what the scores are doing. That's not how I need to do this. This is modulo 0, 9, 10... Oh, this is actually modulo 9, isn't it? Like if the coordinate is 12, the coordinate 12 should be actually 3 on the original thing, isn't it? Oh, no, you're right. It's modulo space.len. Yeah, I'm super dumb. Yes, that's definitely it. Yeah, my brain is melting, as I was saying. Okay, so this gives me the original score. Then so let's say the value was 8. And then we find out that we are, what? 3 to the right. Okay, also, does it matter the direction? I don't think the direction matters, right? Yeah, given that these diagonals are all the same, we basically know that I think we can just add how many times to the right and how many times towards down we are, and it doesn't matter. I think I can prove this. Like going 1 to this and 1 to this is the same. Going to this direction, going to this direction is the same. Going 1 and 1 is the same. So okay. So we don't need to distinguish between left and down. Oh, sorry, right and down. So const tile count. I don't know, tile steps is I need integer division or no, not exactly integer division. I need division without reminder. What is it? div exact? No, div floor, div trunk, right? Yeah, I think the div trunk seems good. Okay, so this tells us how much we need to increase that number. So so here's the problem though. Basically what I would like to do as a starting point is do const adjusted score, I don't know. I would like for this to be basically, I don't know, base score plus tile steps. Modulo 9. No. Is it modulo mod 10? 9 is a valid value, right? Is it or is it not? I'm already going mad. Yes. So it should be modulo 10? But here's the problem though. If I do mod 10, that wraps back to 0. And it doesn't wrap back to 1. And you can't just do plus 1. Right? You could do maybe if the resulting value is 0, then you add 1. Would that work? So here's what I'm gonna do. You know what? I think I'm gonna write a test for this. So const base score equals 8. Var I usize equals 0, and then while, oh no, I don't want this. I wanted this. While I is lower than, I don't know, let's do 5. We do this. Can I do SD? Oh, you know what? Oh, there's also this problem that tests are not super nice for printing output. I just want to print stuff. I don't want to have like a nice test. So never mind. Let me change this to main2. This is gonna be momentarily our new main. So this is gonna be I, and this is gonna be the other thing. So base score plus I modulo 10. Oh, you know what? This needs, I want an if statement in it, so I'm gonna put it out. Well, no, var x equals this, and if x equals 0. Oh, I already know that I can't do this. Holy shit! At least not this way. But let me just do it. Plus equals 1. Then we do x. Okay, let's see how this is. Missing semicolon found identifier. Yeah. Unused constant variant. That's not what I wanted to do. That's what I wanted to do. Unused local constant. Holy shit. Please, Zig, please, I beg you. Okay. Use an declared identifier I. Fair point. This needs to go in here. Eight, 9, 1, 1, 2. Yeah, no. So you can just cheat with an if. Okay, I think I know. I want the modulo stuff to work normally. It's just I need to offset by 1. So I need to actually offset it by 1. So I can do maybe -1 here and +1 outside. Almost? Wait, was it actually modulo 9? Is this it? I mean, it's working. That's the numbers that we want. And we can test this more, I guess. I think that's the function. So let me lift it entirely. So our adjusted score is gonna be this. I think we can also delete this. It's working. So then this is gonna be our adjusted score. Then we queue it back. And then we're good. Thank you for the follow, Fink. Is it Fink? I think it is. YOLO? Should I try it on the tiny input first? 3, 1, 5. Yeah, let's try it to the tiny input, on the tiny input first. And let's make it compile also. So yeah. No field name Y. What? Space.len. Panic integer underflow. Oh no! I'm dumb. Oh yes, and I mean I am dumb, but okay. I thought this was worse. I just needed to readjust the numbers for the test input. Result 40. Not great because it's our end thingy. That's not correct. $315. $315. What do you know? So back to the big input. This goes back to 100. YOLO? Ouch. 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 So, not good. There's something wrong. Also, if it's not ending, are we using known space stuff? Try release fast. I don't think this should be, maybe, but I don't think this should be it. So let me think. The question is there anywhere else where I need to multiply something by 5 and I freaking forgot? And also, is this correct to multiply this by 5? Yes, because the coordinates are gonna be 499, like the exit coordinates. So this is okay. X and Y are real coordinates, and we modulo them when we want to get information from our reduced space. We check everything correctly. This should be fine. Why do we not hit? We are basically not hitting this. Let's log maybe P, the point being considered. That didn't help much actually. Okay, let's do P and then a new line. Okay. So the scores are increasing. So that's good, I guess. Now it's having a lot of trouble to increase that score because there's a lot of stupid candidates with the same thing. Huh. I think there's something wrong in our Dijkstra. So let's look at also the coordinates. Like x is going, like we're stuck in this position. We're like not even moving. Like 160, 158, 161. It's not really making much progress. I think this one should be doing better than this, shouldn't it? I'm using mod 9 for that will cause cycles. Fuck, I am. Yes. What do you mean it will cause cycles? I'm using mod 9 for the extra score. I'm a moron. No, I'm not a moron. That's the adjusted score. That is fair. Above 9 or up to 1. I think I did this correct. Oh man, I deleted the function, but like I printed it earlier and it was working correctly. It was doing 891. Yes. I think this is correct. Oh, you know, there's also the problem that like the matrix now it's I think the overall matrix is somewhat symmetrical. So there's something that what approach are you using? It's just Dijkstra. It's Dijkstra, but it's the modified version, and I think I might have modified it in a bad way. So here it was actually, so it was trying a ton of basically, it's getting stuck in the same place along the two symmetrical sides, and it's sitting there and just scanning a bunch of things at 656, not improving. Is this the moment where you add A star stuff? Part 2. You don't have coordinates that go past 10 in part 1. Also, wait a second. I'm dumb. No, sorry. You have them past 100. You don't have them past 100. That's what I meant to say. You don't have coordinates past 100. You check known space. I do check known space. Yes. And I should not have deleted that check, I think. So, yes, I only add them if they are not part of known space. And known space starts at false. And it's 5 times as big a space. And if this access was wrong, is this really actually just a matter of doing release fast? I don't think so, though. And I don't think this is it. It's not released fast. It's never released fast. So the new points score is score plus adjusted score. I think I can try to print the matrix, like the bit one from the original input, but the original input actually worked. I got the correct answer, so I don't think it's a matter of correctness. Then I don't know what it is. So here's one thing that I can do. One thing that I can do is... One thing that I can do So, am I wrong in saying that the resulting matrix is like completely symmetrical? Like this block is equal as this block. Yeah, no, but that's... So I was thinking maybe of cutting something, but like, it won't work. Rishabh, I'm not using this logic, so like this doesn't have any meaning for me. I don't have any expand rows, expand columns. Or rather, okay, I think I see your point. Like you're saying, make a giant matrix. I'm not making a giant matrix. I'm keeping a small matrix. And then as the indices increase, I look the original score in the original matrix, and then I compute how much the resulting value, like how much the score would have changed in that corresponding tile by doing this tiny piece of math. And I do set it to NP the score. Okay, you know what? Let's do release fast version, I guess. And maybe let's do... I don't know, at that point the prints are not gonna be nice to have, but... even then... So I make some progress. Oh, you can early out if your point is already explored. That might help. I think I'm doing it. Or you're saying the point P. So like if the point P is already through before we got there, then do it. Although because of this, the point P should never be in here twice, right? That shouldn't... The Q can have duplicates. There does seem to be some duplication in here, isn't it? Okay, we don't even have to ask. We definitely do have duplicates in there. Okay, let's do it. If known space we just toss it away. Let's see. Holy shit, that does make a big difference. Let's go. Yay! That was it. That was it. Yeah, two neighbors can have the same point. You know what? This is the same problem that was messing with me in the bomb example, right? In the bomb exercise, I also had the same problem because I didn't realize that two different things were going to push in the queue the same thing twice. Yay! Okay, it wasn't that bad. So this was what? 1 hour 48? That's reasonable. Considering that, well, I didn't implement the priority queue. I did implement Dijkstra though. I'm proud of that. Thank you everyone who helped. I store cost instead of visited. Moves which shuts down the duplicates even further. Cool. So that's it, I guess. It wasn't that bad, but it was very... I mean, you know what Dijkstra does. You realize that the problem is a Dijkstra problem, and then you apply Dijkstra, and then you are forced to get clever with modulo stuff. And that's pretty much it. This was kind of important. Did the pseudocode on Wikipedia? I ended up not even looking at the pseudocode of Wikipedia. Does it say this? I hate these stupid pseudocode explanations like, you add it with infinity. Yeah, sure. Where did we use infinity in our implementation? Nowhere. Why is infinity a thing in pseudocode? Like, can you avoid the concept of infinity in your explanation of stuff? That doesn't help anybody. Those arrows don't help anybody either. But anyway. So remove Q. So while the queue is not empty, pop one. Also, okay, just say pop, dude, please. Okay, pop. And then grab all its neighbors. Still in queue. So this still in queue basically is our not visited stuff. This is, I guess, our new score. I have no idea what this thing is doing. This protocol is so bad. But it doesn't seem to be saying the same things that we are saying. We're only interested in the shortest path between vertices, source, and target. Determine the search after line 15 if u equals target. Now we can read the shortest path from source to target by reverse iteration. Empty sequence u target if prev u is defined or u equals source while u is defined. What are these explanations? Oh wait. Oh, this is a pseudocode without the priority queue. Oh, this is a normal queue. That's why it's like giving extra information. Okay, sorry. Using a priority queue. Is this any better? So, for each vertex in graph, add everything to the queue. Why? Set to infinity. Why are they not just expanding the frontier? I seriously have trouble understanding why this stuff is explained this way. Oh, okay, pop the mean. Compute the new distance. Oh. 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 So we were not doing this, were we? No, wait, I'm not sure. What the heck is this line supposed to be? It allows them to have one data structure for is visited and get mean instead of two. I just think this explanation is a disaster. Like, okay, so what's a queue in here, in case? It's an array, okay. You basically put stuff in an array with the proper order. So, okay, at the end of the day, maybe it's not that bad. I don't know, though. We weren't doing the this check, were we? Like, what does this doesn't correspond to anything that we were doing, was it? Because we were just expanding the frontier and we weren't thinking much. Oh, wait, I think this connects back to your change. Instead of having just a bool for visited, you store scores in there, and that's when you can do this. You look at the thing for the visited stuff. If it's, and here's the stupid infinity concept comes into play. So you look at your matrix where you keep score, when you keep track of the other scores, and you say, oh, you know what? I already have this node with a better score than this one. So unless yours is better, don't add it. Can I change it? Can I change my stuff to be like yours? let's see. So instead of bools, we make a known space of usize. Oh, that's a bit too big. Let's do u32. So known space has u32s in there. Oh, but it's gonna have type stuff. Okay, you know what? Usize. I bought the memory. I used the memory. So these are gonna be usizes. So whenever something is known, instead of saying it's known, what am I going to do? I pop P. Is it when I pop P that I try to set its score? Or do I do it in here? I think it's better to avoid adding stuff. So I don't do this, I think. But inside of here, if the coordinates are valid. Oh, I don't know yet the new score. So I don't do this. What I do is, okay, give me the new score. This is the new score that you got. Well, is it better or worse than what we had? So const best. Let's do last. Best is going to be known space np.x np.y. If last best is greater than 0, we don't put zeros in there, maybe. So we only do this like this check if the value in there is not 0. You use 0 as infinity. So if the last best is greater than 0 and np.score is lower than last, or actually no, is bigger or equal than last best, then we just don't add it, we continue. Otherwise, we need to update last best. Is this it? Is this the correct value? I don't remember. No, I don't think it is. Is it? Wait, refresh. 2993. Oh, yes, it is. Okay, so it's the correct value. And I think we got there even faster than earlier. So that's how they were encoding. So I wasn't doing this, and that's why I kinda needed a check in here to make things less bad. You actually don't need the first check. You can't have a lower cost after a node has been visited. What's the first check then? Specs. You mean this? The first check. What's the first check that you're referring to? I don't need to check for in queue. Are you talking about stuff in my code? Because I don't think I have this. Sorry, I think I'm just not. I think I'm just missing what you're trying to say. That's it. I'll give a bit of time to actually type it up. Sorry. ended up removing my A-star solution as I couldn't get it to be faster than my D-star solution anyhow. Like A-star, it's worth it when the heuristic is worth it, right? So I guess the question is, can you find a heuristic that's good, that's worth its weight, like its complexity? And unless you can find a good one, it's not useful. I really think like a space like this is like a somewhat homogeneous space. So it's like the thing is, I think we agreed that knowing that like you can bake into it that the knowledge that the exit is down right. But that's not even much of knowledge, because down right doesn't mean much, right? When you're going inside. A little bit maybe, but not apparently, according to Martin, not enough. If you had like a space where you had, I don't know, like blocks of like a grid of cells, a bunch of cells where you can't go, or like, I don't know, let me give you a pretty dumb example, but I think would be telling. So let's say that you know that up here there's like a complicated maze, and down here it's not a complicated maze. So even that knowledge could just be enough to say prefer going down than going right. And so you could add a heuristic based on the x and y coordinates, right? So you say if you're like deprioritize this, assume that going in this upright quadrant is a bad idea, so try the rest, try down first. So maybe that could help. But unless you can unless you can inject some good extra knowledge into the search, it's not worth it. Okay, so let's say what Martin was saying. Wait, oh, this is the other chat. Yeah, last check greater than 0. Fill the array with max cost instead. Oh yeah, I see your point. So you're saying do proper infinity. Yeah, I could do proper infinity. I think the main problem is, you know, I mean, fair, but at the same time, I don't know. I don't like the academic explanation of this stuff. I think it's boring. And maybe one shouldn't have to worry about like the mechanics of the computer too much in the beginning, but I don't know, the like tossing around the concept of infinity, which okay, it's like int max, whatever, it's kind of dirty. I think the main problem is the Manhattan space here, as that means every single point is part of the shortest path to the goal. You don't necessarily have to use Manhattan space if you think it's suboptimal. Like if you want to encode the diagonal concept more cleanly, just do the approximated length of the diagonal, I guess. That will not overestimate. That will give you a number that's going to be definitely lower than the reality. But even then, I don't know. I just think that it might just be that it's not worth it. You don't. You're like the question is, how much knowledge are you adding to the thing? If you can add like knowledge that the algorithm doesn't have, and you can add a ton of it, it's definitely going to be worth it. But otherwise, I think that's it. What I'm trying to say is that there is nothing that says that there is any point of following the diagonal. I mean, no, yes, but no. I mean, in the example, following the diagonal, or like staying close to the diagonal in the beginning doesn't help much, but once you get here, it helps a lot. So I haven't checked my solution and how it looks like, but at least this one, that doesn't seem wrong. And when we say diagonal, so, sorry, I don't know what other people meant when they said diagonal, but in my case, when I say diagonal, I don't mean the diagonal of the entire thing. I mean the diagonal from your point to the bottom corner. So Here, I don't think it would be that bad, right? Maybe it would help a little. I don't know. In any case, apparently, if you do implement Dijkstra correctly, you don't even have to worry much. Why do I have another of these things open? What? No? Well, that's it. If nobody has any other question, I think I'm gonna call it. Nice. That was not too bad of a day. So let's see how it's going in the leaderboard. Bags, of course, on top, owning everybody. Nice. Ooh, I'm position 40. Holy shit. Everybody's taking AOC so seriously. Like, there's people that haven't done... Oh, they have done only one exercise and they're still above me. Oh, I'm spending too much time chatting with people, am I? You touch the same number of tiles going along the diagonal as going along the edge, so it might be wrong to follow the diagonal. That is fair, but... That is fair, but also... So if you try to metagame this a little bit, would you say that it's more probable that the answer is a diagonal than it is any other shape? Or let me put it this way, let me rephrase this a little. Wouldn't it be fair to say that the biggest part of the answer is somewhat diagonal than anything else? Given how the exercises are structured. So like, you don't know, right? They could make any, like they could ask you to go down, then right, then up, then like do a proper maze with like sharp turns and stuff. They could make something weird like this, I don't know. Or they could make an answer where going to the board, where like, yeah, following the borders is the right answer. But at the same time, I think you can expect them to mostly generate stuff that looks like this. So I don't know. Yeah, also, on that perspective, I'm also pleasantly surprised by how many people are streaming Zig lately. So I started with the idea of doing Bork and Suzy and everything else to help people stream, and then some people picked the idea up, but not everybody. And I would say there wasn't a ton of people streaming Zig until recently. Now there has been an explosion, so I think now I've committed to do the Advent of Code, so I'll do the Advent of Code. It's like 10 days remaining. Hopefully I'll survive. But I think that after that, my goal should be to actually continue polish this tooling and make it and improve on it. Like, I think I want a Suzy Twitter account that automatically tweets when somebody goes live streaming Zig. It's basically the same concept as Suzy here. Like, I would want to add this functionality actually to the same bot. So it tweets out when somebody goes live, and maybe we could finally also have it publish a message. I'm not sure. I will have to talk with people. I remember that publishing a message was more complicated to make it work nice. There are more paths close to the diagonal, but as there are, but this duplication doesn't matter. You have more choices along the diagonal, but using L2 distance heuristic is lower than, yeah. Yeah, I think that at the end of the day, it's not that good. So, you know, I wasn't thinking necessarily of having more choices. What I was thinking is that the algorithm that they use to make these things is probably going to mostly produce this kind of stuff with some variation that's probably not that giant. Like, for example, exercise 13, I think. Like, exercise 13, I believe everybody got the same set of folds. So in the, where is it? What's my input? I think everybody got these same exact folding rules, but we had different starting points because these starting points were generated from different letters, right? So the randomized part was the letters for your part 2 input string, which then would correspond to these points when folded backwards from these rules, and also randomizing every time they applied, I guess, this fold in reverse, they also randomized whether the point should have been on one side, on the other side, or on both sides. So from that perspective, maybe all the inputs kind of do this thing. Anyway, it doesn't matter. It's not that much of an improvement. Okay, it was hard to get good speeds here. This day took as much time as all the others days put together. Did you? For you? Oh, for me, yesterday was harder. I guess it depends a bit on what you know better, what you don't know well, and stuff like that. In any case, let me see if we can raid somebody. Can I counter shame raid somebody today? Oh, you mean execution time? Oh, I see. Well, I guess when you're doing this type of exploration, there's not much you can do. I mean, I think Dijkstra is optimal, more or less. I think it is optimal. I don't remember precisely, but like, once you have Dijkstra, that's it, pretty much. So, looking for a Laravel job. So PHP stream, DevOps stream, game dev, blockchain on Camel. Is there really like no lower level stuff? Maybe this one. I have code day 15 in Go. Okay, let's do the one in Go. There are definitely optimizations on Dijkstra's, but they need a custom heap structure. Well, everyone, thank you for stopping by. See you tomorrow. Bye.